So this is the first part of several measures of central tendency and variation. We're going to pick this up in class because if you notice on the syllabus, this goes for several days because there's a lot of information in 10-4. So we're going to scratch the surface a little bit today, and then we'll pick up more of it next week and the week after that. So measures of central tendency is one topic. Variation is another topic. So we talk about measures of center and measures of spread. Why do we even talk about these things? Because we want information about the data set that we have in front of us. So whatever it is that we've collected, right? Assuming we've collected some set of data, let's find out some information about the data. Let's give some numerical way to summarize it so that we can get information about the data set and so we can compare it to other sets of data. So measures of center give information about the average data point, the number that best represents a group. So the average data point, that's the mean. But could there be other ways to represent a data set? Which one best represents information about that data set? Measures of spread talks about how wide the data set is. And if you look at those New Jersey Student Learning Standards, the Common Core Standards, you'll notice that a lot of this is included in the 6th grade standards. So not only for your own sake, but being proficient to teach it if you're going to be teaching in the 6th grade, a lot of that is being pushed down to the middle school level as well. So some of this I'm sure that you have some familiarity with. Measures of center, also known as measures of central tendency, mean, median, and mode. Mean is the average. Simplest thing, add up all the test grades, divide by the number of students in the class, you have the class average. You want the average speed that somebody was traveling, add up all the speeds, divide by the number of cars, you've got average speed. The median is the value of the set in the middle. So if you went out to Route 22, right in the middle of 22, you would see a big grassy thing called the median. Where's the median? It's in the middle of the road. So the median in a set of data is the middle value of that set. If the set has an even number of elements, what you end up is doing the average of the two in the middle to find the median. So if it's got an odd number of data points in the set, then it's easy. It's the one exactly in the center. Otherwise, count up from the top and bottom, average the two in the middle. The mode is the one that occurs most often. Sometimes the mode is a good measure, sometimes it's not. If a set has two modes, we call it bimodal. If it's got any more than two modes, it's not really useful. It's like if you took a set of tests and 2 people got a 78, 2 people got an 82, 2 people got an 85, 2 people got a 92, and 2 people got 100. What does that tell you? It's quintmodal. That really doesn't make any sense. So much beyond bimodal is not really useful to us. All right, for means. Mean is the average. You know how to take an average, add up all the numbers, divide by the number you have. So we call it an arithmetic mean. Yes, there is something called a geometric mean. We're not going to worry about that right now, but there is something here called an arithmetic mean. So take the numbers, the first test score, the second test score, the third, the fourth, the fifth, and so forth, until you get to the last person in the class, add them all up, divide by the number. So if you want the average temperatures for the month of January, you would add up the temperature on January 1st, plus the temperature on January 2nd, plus the temperature on January 3rd, all the way till you get to January 31st, then you divide by 31. So you're going to add up all the numbers, divide by the number in the set, and that X with a little bar on it is the notation that we use for the mean. Okay, so if you see arithmetic mean, it's just the mean, it's just the average. So rather than just give you a pile of numbers and ask you to find the average, I'm going to give you this problem here, in case you see it on a lab somewhere perhaps. So suppose your 5 test grades are listed here, right? 82, 89, 85, 95, and 91. Suppose the final exam counts as 2 grades. Determine if it's possible to get an A in the class. And I'm defining an A as a grade of 90 or above. And if it is possible, what grade would you need in the final exam? So here I am. I'm going to calculate my average, except that really I have 7 grades, right? Because it tells me that the final exam counts as 2 test grades. So 2 test grades for the final plus the 5 that I already have. So my grades are 82, 89, 85, 95, 91, and a double grade that I haven't figured out what it is yet. Divided by 7 because there's 5 test grades and then the final exam counts as 2 test grades. I would like that to be greater than or equal to 90. I'm running off my screen here. There we go. Well, let's do the first part and make this a little bit simpler on the top. I'm going to grab a calculator. You can't see it, but I promise I have a calculator. 82 plus 89 plus 85 plus 95 plus 91 is 442. So I get 442 plus 2x over 7. I want that number to be greater than or equal to 90. First thing is, let's get rid of that 7 in the denominator by multiplying both sides by 7. So I'll multiply this side by 7, and I'll multiply that side by 7. All right, when I do that, 7's cancel top and bottom. I get 442 plus 2x. 9 times 7 is 63, so greater than 630. All right, a couple of quick algebra steps here. Let's get rid of our 442 from both sides. All right, 630 minus 442 is 188. All right, so there's hope for me, because if this number were above 200, then I would need more than 100% on the final exam, and I can't do that. So the fact that it's less than 200 says to me, yeah, it's possible for me to get at least a 90 in the class. What's half of 188? It is a 94. All right, so I'm going to have to study a little bit, but as long as I get a 94 or greater, I'll get an A in the class. If I get anything less than a 94, then I'm not going to get an A in the class. All right, so that's how I do it. All right, the median is the one in the middle. So we're going to take the scores or the housing prices or the temperatures for the month or whatever, arrange them highest to lowest. This thing I took from the book says least to greatest. I'll bet you could do a greatest to least and you'll get the same answer. All right, if you have an odd number, it's the one in the middle. Even is just the average of the two in the middle. So we'll take a look at an example in a couple of minutes that will show you how to do all this. And then the mode is simply the one that appears most often. Right, the mode is sometimes a good measure of the data set, sometimes near the sometimes not. It's not always near the center. In other words, if you gave a test and 2 people got 100 and most of the rest of the class got B's and C's, the mode would be 100, even though the average might be a 78 or something like that. So sometimes the mode is helpful, sometimes the mode is not. So let's look at this example. All right, this is an example I have that has housing prices. Sale prices for houses in Hunterdon County last month in thousands of dollars. This is totally made up data. So don't go looking to see if it actually was. It's not. So all these things are listed in thousands of dollars. It says find the mean, the median, and the mode of the set, which is the best indicator. So I'm going to come over on the side over here, and I'm going to make myself a list from greatest to least. All right, so remember the 1380 is really 1,380,000. I just tried to save us from having to write all those zeros at the end. So that one's the highest number. As I do it, I'm going to cross them off so I don't lose any. Looks like 1,300 is next. All right, maybe 850. And then 670. And 625. And I got a couple in the 500s. They look like they're all on the right side. So 565 is over here. 540. 500. And then am I down to the 4s? It looks like a 448 is next. 300s, I got a 370 over here. Next to the 370 is a 350. And now I'm down to the 200. So I got a 238. Couple of 235s. All right, so here's my 238. Couple of 235s. That takes care of everything except the 215. And the 180. All right, so I had 16 prices up here, right? 1, 2, 3, 4, 5, 6, 7, 8, and double it, I get 16. So I should have 16 on my list. Let's just count to make sure, and we'll make a mark at the halfway mark. If I start up on the top, 1, 2, 3, 4, 5, 6, 7, 8. On the bottom, I should have 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. So if I want the mean is add them all up, divide by the number in my set. I didn't tell you what the sum was, did I? All right, then I'm going to have to add them all up. Give me a second. I'll add them all up, and I'll come back to you. All right, so I added them all up, and I got 8701 for the sum. So 8701 was the sum of all of those numbers. And then I'm going to divide it by 16 because there were 16 houses that were sold. So 8701 divided by 16 gives me a mean of, if I put it back in dollars, $543,813, right? I got 543.8125. So rounded to the whole number of dollars, $543,813. There's the mean. All right, let's try to find the median. Notice that when I was counting them up and down, I put a little mark at the halfway mark. This set of data has an even number of items in the set, so I can't just look at the one in the middle because there is none in the middle. So what I do is I take the average of the two in the middle. So for the median, right, there is no median, there is no housing price that's exactly in the middle, so take the average of the two. So 500 plus 448 divided by 2. Gives me 474. So the median housing price, $474,000. Okay. The mode is the one that occurs most often. So let's look to see, now that we have it listed from highest to lowest, we can see if there's any repeats. The first half does not have any repeats, from 1380 all the way down to 500. I got to go all the way down to the bottom here to find two housing prices that repeat. So $235,000 is the mode of the housing prices. Out of these three, which one best represents the data set? Whatever I pick, the answer is not going to be the mode. So if you want to know what kind of houses were for sale or were sold in Hunterdon County last month, the $235,000 was way down the bottom of the list. So that does not represent the typical housing price. The mean or the median is a good indicator. The median is actually probably better because we say the median is what we call a resistant measure. And what we mean by that is that it's not affected by really high and really low values. So the $180,000 house bringing the price down was more than counteracted by these $1 million+ houses and this guy that was $850,000. So those really expensive houses brought the whole set of data higher, right? So that mean is higher than the median. So oftentimes when you hear housing prices discussed in the news, you'll hear median housing prices. You'll hear median income for a certain town. Why? Because those measures are less resistant to very high values and very low values. The mean, on the other hand, includes those high and low values, and it can make it higher or it can make it lower, depending on whether you have a lot of them at the top or at the bottom. All right, let's give some more examples, but let's give it in a separate video from this.